A question from alcohols, phenols, and ethers. Write the mechanism of the following reaction. Ethanol on reacting with H plus, that is acid, at 443 Kelvin, giving alkene, ethane. So this is the acid catalyzed dehydration of alcohol. So the reagents that can be used are, say, a protic acid like concentrated H2SO4 or H3PO4 or anhydrous zinc chloride or alumina, and the temperature 443 Kelvin or 170 degrees to 180 degrees Celsius. Now this is the dehydration of alcohols carried out with the help of protic acids like concentrated H2SO4 or H3PO4 under high temperature. So this acts by the cleavage of the carbon-oxygen bond. Now the mechanism of this reaction can be divided into three parts. First one is the formation of protonated alcohol. Now dehydration means removal of water and protonation means addition of a proton. So let us look at the mechanism. So step 1 is, this is ethanol, CH3 CH2OH. Now oxygen has two lone pairs of electrons on it in the presence of H plus from any of the acids which we are using as catalyst at 443 Kelvin. Now a proton is taken up from here. This is the proton, and what happens? You can see CH3 CH2O will have a positive charge and then two hydrogens attached to it. Now the presence of this positive charge here will make this compound highly unstable because oxygen is electronegative and the positive charge on it will make it unstable. Now the second step is formation of carbocation. So let us see. CH3 CH2 oxygen with this positive charge and these hydrogens. Now this bond or these electrons will be donated to in here, and you will get, or a carbocation is formed, say CH3 CH2 with a positive charge here plus water H2O. Now this is the rate determining step and this is the formation of a carbocation. Now step 3 is formation of alkene. So the product we need is alkene, ethene. So formation of alkene by alpha elimination. So let us bring in this carbocation here. That is, we will write the CH3 like CH2, H, two hydrogens here, one hydrogen here, and CH2 with a positive charge here. This proton, this hydrogen will get eliminated as a proton and these electrons will shift here. Now as a result, this positive charge will be gone and a double bond will come between these CH2 CH2 with the elimination of a proton. So you know that this is the carbocation and this is the alpha hydrogen. So elimination of a hydrogen from there. That is why we say formation of alkene by alpha elimination. So elimination of a hydrogen from the alpha carbon. So that leads to the formation of this ethene. And you started with a proton, you are giving back that proton. So that is why we say this is acid catalyzed dehydration of alcohols. So the reagent is protic acids like concentrated sulfuric acid or phosphoric acid, or anhydrous zinc chloride or alumina. Temperature should be high, that is 443 Kelvin or 170 degree to 180 degree Celsius. The mechanism has been asked several times in your board exams.